the original talk, well, the talk I did before I did this Git talk was about PowerShell and VS Code actually, but I noticed that I started to get more questions around using Git and GitHub in that session that I decided to make it a separate talk. That's why we're here actually. The session is a getting started session. So if you're a developer or maybe an IT professional who has been working with Git and GitHub for a number of months or years even, you probably will not learn that much in this session. But I see many people struggle with the basics, and that's what this session will be about. So the session is aimed at IT professionals, or maybe more accurate, everyone who works with computers in a professional way, let's say. The aim is to give you a decent basis to get started with Git. It's not going to be the most technical session. I've got one demonstration, but I thought it was especially important to give you some basic commands, of course, but the aim is first and foremost to get you acquainted with the concepts behind Git, because there's sometimes a lot of confusion on how Git works and what the philosophy behind the platform is, and essentially why you would want to use it. So on the agenda today, first of all, introduction to Git. Why do we have Git? Why might you think about using Git? What is the origin of Git? What set Git apart from other source control systems that you might already played with? That's the first part. Second part will be the tools that you need to get started. So before we even start using Git on the command line or in a web interface, there's some other things that you should probably install on your PC. So you've already seen people using very fancy command line tools with all playful colors and everything. Those are the tools that we need to work with Git properly. Then I'm going to explain you the basic stuff that how you can work with Git. So that means, how do I, let's call it download code from the internet to look at on my PC? How can I make changes? How can I push them back, etc.? So the basic stuff of working with Git. And then I want to give you a few directions on where to go next, because Git can be quite complicated, especially if you're working with multiple people, for example. So there are multiple directions you might go afterwards. You might want to go and contribute to open source software or open source documentation, because that's also possible. You might want to start right away with your new project and work together with other people, or just have your own private stack of code that you want to work with. So there are multiple directions, and I hope to give you some pointers and some hints on what you might want to explore next. Just a little bit about myself. My name is Thomas Vochten. I'm a technology evangelist working with the Kronos Group, as Geert already introduced me, which is a large technology group in Belgium. I'm also Microsoft MVP, which basically means I like talking a lot. I'm also the president of the Belgian Information Worker User Group. It's a mouthful, we know that. But we do regular events focused on Microsoft 365 and related technologies, and we also organize Collab Days Belgium, and that's the event formerly known as SharePoint Saturday Belgium. If you've got any questions after the presentations, we'll have some time for Q&A, but also feel free to reach out to me afterwards. You can even send me an email if you want. You can always contact me later with any additional questions that you might have. Okay, so I already warned you, it's going to be a gentle introduction to Git. So we're not going to dive into the really nitty-gritty details about the very specific situations. I will touch upon them, but we will not get into the details there. So it's aimed at providing you with an overview of the problem space, why we need Git, why we need maybe GitHub, and how they might help you to get your work done more efficiently. Now, I'm an IT professional. That means that I'm not a developer in Microsoft speak. I know my way around Visual Studio. I know just enough C# and a little bit TypeScript, just enough to be dangerous, to be able to read some code, but I'm by no means a developer. So I often get the question from IT professionals like myself, so admins or tenant admins or people who work with PowerShell, why should I care about Git? Why exactly would I care? Because I strongly believe that they make tools like those make your life a lot easier. IT pros are also entitled to better tooling. Using Git and all those cool tools that seem to be made in the 80s, because they're all coming back, right? It's not GUIs anymore. It's fancy command line interfaces, everything in dark mode with fancy colors. Aren't they just eye candy? Well, they're not, and they can be useful to you as an IT professional. So it's not only for developers. By the way, if you say, I'm using PowerShell, I'm not a developer, well, let me break the news to you. PowerShell is probably also code. So you might still be a coder after all. Developers typically have a lot of, let's say, common good practices like we do in the IT pro space. Some very known ones, and they like to make acronyms, by the way. So we have DRY, which is do not repeat yourself, or KISS, keep it stupid simple. And there's also a very long one, my personal favorite, which basically means do the simplest thing that could possibly work. Don't overcomplicate stuff. Don't over-engineer stuff. So a lot of best practices in the developer world. You might laugh about it because sometimes it is also funny, but IT professionals like ourselves might also learn something here. And today's talk is all about this. So if you're a reluctant IT professional, like myself, asking why he or she would care, please bear with me. Let me show you a very typical example, which might be an eye-opener on how using tools like Git might help you in your daily work. Maybe something like this looks familiar to you. This is, in this case, fictitious screenshot of a file server or a local PC with a few PowerShell scripts. We got script to do stuff PS1. We've got script to do stuff version 2 PS1. And then we've got a version 2 for customer A. We've got a version 3, a version 4, a version 4 that we're using at customer B, etc., etc. We even have a few PowerShell modules here. So when it's in your face like this, it's pretty obvious, I guess. But everyone has faced the same problem. For the longest time, I kept my PowerShell scripts in File Explorer or on OneDrive, but I also had scripts in OneNote, for example, or on a file share or some other cloud storage platform. So you end up with a pile of scripts that are hard to manage because I don't exactly remember what I changed between version 3 and 4. And the version that we deployed at customer B was significantly different than the one that we deployed in customer A. But what do I do if I want to make changes to both customer scripts, etc., etc. So it's hard to manage. It's hard to maintain. You don't know which file is being used where or what the latest changes were. If I'm from the Microsoft 365 space, I've been doing SharePoint for 15 years. It's very recognizable. If you talk to business users and you try to explain them the benefits of using version control in SharePoint, for example, it's exactly the same problem. Exactly the same. It's maybe a little bit more complicated, but the basics are the same. So what if you want to make changes? That's a problem. What if you want to change something? Well, you need to have a new name. How do you come up with a new name, etc., etc.? Very complicated. It even gets worse if other people also contribute to the same scripts. You can all point them to the same file share if you want, or you can share a folder in OneDrive. But there's definitely a better solution, and that's using source control. So why would we use source control, or what are the basic premises of using a source control system? So it's basically version control for your code or scripts. In our case, if you're a developer, it might just be code. But make no mistake, you can store more or less everything in a source control system and in Git. So you can store images there if you want, or Word files. It won't work the same as with SharePoint, but you can do that if you want. You can store and track almost everything in a source control system and in Git, because that's what we're going to talk about today. By the way, don't be confused if I talk about code or scripts today. Those are interchangeable. It's stuff you store in your source control system. So it allows you to keep different versions of your files, maybe one for production, one for test, one for customer A, one for customer B, maybe a basic script and then a script that you change to do something additionally fancy. Source control. That's basically what it provides us. And because it's changing everything you change is tracked and traced inside of the system. There's also an ability to go back if you messed up. And believe me, I messed up a lot, so that comes in very handy. So if you change something, you save it in traditional file system, it's gone. What if you want to go back? You can even compare the changes between different versions. I know I had a version of the script that did something like this 5 months ago. Well, you can actually go back and look at that file 5 months ago and compare that with the files that you are using right now. What makes it particularly powerful is that you're able to work together with other people. Granted, you can also do that if you keep your scripts on a file share, but then you easily end up with this naming convention mess, and everyone starts renaming the files and copying them to make sure that no one else is changing it, etc., etc. So other people can also collaborate, and everything is tracked. Something that you might not have thought about already is that it enables you to work on new stuff while keeping the existing files intact. As everyone is looking at the same, let's say, base version of the truth, you can make a copy. It's not really called a copy in source control, it's called a branch. You can create a branch from that code and you can start make changes to it. For example, for a new feature, or you might fix a bug or something like that. And then when you think you're ready, you can merge, that's called merging, back into the original file, and everyone can take advantage of the stuff you changed. So that's quite important. And also the other way around. Let's say you're working on a new feature, or you're changing your script to grant licenses to everyone in your Microsoft 365 tenant for a particular feature, and you're making some changes to the script, but in the other, another colleague wants to change something completely different. Well, you don't have to work with the same exact physical file. You can all work next to each other and then merge these changes back into the system when needed. And there are another long list of possibilities. Okay. Well, this session is not about source control in general. The session will be about Git and why Git, because Git is the de facto standard. You have other version control systems too. I worked a lot with, what was it called? Subversion in the time. I mean, 10, 15 years ago. And I even worked with, God forbid, Microsoft's own Visual Source Safe. I hope you have never worked with that, because that was quite interesting. But even now, there is Microsoft Team Foundation from Microsoft, which is still used today if you want. But I think the world has more or less settled on Git and the related technologies and related products. So Git has been created by Linus Torvalds, the founder of Linux. You might know that name, in 2005 already, because he needed a better way to coordinate with other Linux developers. So the origins are Linux. That's also why it's command line, probably. If it was invented by Microsoft in 2005, it would probably be a horrible GUI. He named it Git, by the way, and that's a nice no. Because it means a Git is someone who is very annoying in the British slang, and if you know Linus Torvalds, you know he is a bit annoying. So yeah, a lot of self-knowledge there. So it's a description that matches his own character very well. So the philosophy for Git, when he created it, it was to make a version control system that is fast and powerful, and it's absolutely that. The magic word on this slide, by the way, is not Git. It's not free. It's nice that it's free and open source, but it's distributed. And distributed is one of the ways that sets Git apart from many other version control systems, but it's also the word that makes it sometimes a bit more complicated than another version control system. So let's go over some key concepts, stuff you absolutely need to know when you're working with Git. A lot of these words you might hear people throw around when they're talking about Git. It's important that you know them. First of all, branching and merging. It's not maybe immediately the most basic concept, but it's one of the things that sets Git apart, and it's one of the defining concepts of the system. So what makes Git stand out from other source control systems is that it allows and encourages you to have multiple local branches, and that's what is depicted in the picture there, for different purposes, to try out an idea, to work on a new feature, to fix a bug, or something else. And when you're done, you can switch back to what is in this case, in this slide, called the master branch. It's like from a tree, right? The master branch or the trunk. In Subversion, it's called the trunk, by the way. So there's a tree analogy. So everyone is able to work on their own version of the code, and you're able to merge your changes back into another branch if you want. And from one branch, you can create another branch and another branch and another branch until you don't know where you are anymore. So it's quite possible. It's quite interesting. And that's why it's often called, it's also a hierarchy, more or less. The main branch is often called master, but over the last year, people have been changing that to main. And also GitHub, we'll talk about GitHub in a few slides. For example, they have changed the default to be main, but it's just a convention. Many things in Git are conventions. The tooling system is not enforcing you to use master or main or whatever as your main branch, by the way. So many conventions here. A second concept, and that was the word on the previous slide, distributed. It's also something really hard to get your head around in the beginning, because if you work with other source control systems, they are not distributed. There is one, let's say, main version of the truth, and everything is related to that. But it's not that case in Git. So everyone works on their own copy of the code. You don't need to check out code, for example, as is done in other source control systems. So you might have a repository, and that's where the code lives, a repository that is considered also a convention by most of the people that is the main version, but that is a convention. So your own copy, if you have a developer, you download the whole code, it's standalone with a full history of changes and everything. So it can stand on its own. That's also quite important to know. All right. Another thing that sets Git apart is the concept of staging. And that means that if you made a change, or if you made 25 changes to the code, you can choose to only add one single change back to the system, or all of them, or 20 of them. So that's a staging area. So you are in your working directory, you're changing your PowerShell module, and you're maybe changing 5 different files. Then you need to tell Git, okay, and these 5 files, I want to add them back to the repository. That's called staging. That's also a little bit different than many other source control systems do, where it's often an all or nothing story. Git is also supposed to be small and fast, and it is small and fast if you work with large code bases or very large repositories. Making operations is really, really fast. Creating a branch is really, really fast. There's also a certain robustness built into the system so that stuff doesn't get corrupted easily. It's really, really robust and powerful. If you create a branch, it's not that a whole code base is copied physically to another place and you have to wait 25 minutes. No, it's all done very, very fast. All right, we talked about Git. What about GitHub then? Git is the source control system. It's a server, it's free. You can download it from the internet. You have to download it actually if you want to work with the code. So if you install Git on your PC, you have a complete standalone source control system. But it's always better to link that up to a centralized source control system for safety reasons, that's like backup, and convenience, so other people can also connect to the same repositories or the same code. And that's where GitHub comes into play. So GitHub is basically Git, but in a hosted version. You install Git on your PC, that's your local version, and Git is also installed on a server centrally in GitHub. GitHub has been acquired by Microsoft 2 years or almost 3 years ago. And well, it's maybe a little bit over the top, but it's also the de facto standard. Most open source systems use GitHub to store their code, but there are also alternatives. These are some other alternative central Git repositories or services that you might want to use. There's Bitbucket, there is GitLab, and there's also Microsoft's own Azure Repos. And Azure Repos is also owned by Microsoft, of course. But since they acquired GitHub, well, there's a little bit of a tension there, maybe. So if you want to work together with other people, you can use GitHub to store your code or your scripts. You can get a free account there. You can have free repositories, public repositories, private repositories. There are some paid plans if you want to do some additional stuff like automatically checking your code for security vulnerabilities, stuff like that. Then there's a paid plan. But if you just go to github.com, you can create an account if you don't have one already. I'm going to take a sip of water. So that's all really, really nice and cool. But when you hear people talk about their first experiences with Git, well, people often get confused. And even more seasoned developers or people or administrators that have been using Git for a long time, sometimes they moan about how complicated Git can get. And this cartoon, well, really sums it up well. So it basically says, okay, if you don't know what you're doing anymore because Git made a mess or you made a mess, just erase everything and start all over. Exactly the thing that we didn't want you to do, and exactly the thing that you might have done before when you messed up all your PowerShell scripts. Let's just delete them and retrieve them from backup and start all over. Exactly not the practice that we want. And this is typically the moment in this presentation that I hate speaking. I realize I hate speaking at online events because I don't have any idea if you're at least had a smile or a little bit of a grin, or that this made you think of the dinner that you need to make when this session is over. So yeah, that's a pity. So I can't read the audience, but so Git is cool, but it can be complicated. And hold on, there is even more. It's even so complicated, and so many people have well, regular problems with it that someone created this website. So it's ohshitgit.com, and it's a whole website dedicated to fixing horrible mistakes that you made while using Git. I've personally used this site already maybe 20 or 30 times over the past few years. It was recommended to me by Andrew Connell, a SharePoint developer. Because Git is complicated or can be complicated. The basic operations are not. You will see that the basics are, well, quite simple or relatively simple. But it's, yeah, this site will teach you what to do when there is a problem. If you, for example, committed something to the wrong branch, you thought you were working your own branch and you committed to the main branch so everyone can see it. How do I reverse that, for example? When you committed the same file, the wrong files, for example, or you need to make a change, or you didn't add something to a log, or stuff like that. It's a small site. There may be 15 common scenarios in it, and that's it. But it's really some site to bookmark. And if you think this site is a bit offensive in its language, there is also dangitgit.com, and there is also localized versions which use a little bit less strong language. Definitely something to bookmark. Okay, so before we dive into the demo and have a look at some basic Git commands, let's look at the tools you need to get started with Git. And we're all geeks, so we love tools, right? What I install on my system to get anything done with Git are these three tools. Now, on the left-hand side is Git itself. You can download Git from the internet. It's free. It's open source, as we already said. Then you need a terminal to interact with the source control system with Git. You can use command line, the command prompt. You can use PowerShell. You can use Windows PowerShell. You can use anything basically. But I like to use Windows Terminal. So it's really nice. You can also apply special coded effects to it, which I will show you in a few seconds. And then there's also Visual Studio Code. You don't need to have Visual Studio Code to work with Git, but if you're like me and you're working with PowerShell a lot, that you want to check in to a source control system to Git, then it's really nice because Visual Studio has a lot of cool integrations. So the only thing you really need is Git and an interface to interact with it. That can be the command line. And if you install Git, you get a Linux-like interface already built in, but I don't like that interface. It's a little bit too archaic. So I want to use something else, Windows Terminal and Visual Studio Code. So the only thing you really need is Git. By the way, you don't need to use Visual Studio Code or a code editor to work with your files in Git. You can work with Notepad. You can work with Word to make changes to your files. You can make changes in Windows Explorer if you want. Git will all take care of it. Now, if you're a little bit intimidated by using the Windows terminal or a command line interface all the time, there's also alternatives. So in order to work with the command line interface, and that's what most people typically do, and I advise you to start there, because learning the basics is often more simple when you just have to type a few commands. It's better for your learning experience, but then you have total control. But if you like a more graphical approach to working with Git, there's also a desktop user interface like this one, GitHub Desktop from GitHub itself, but there are also other vendors that make Git clients which have certain unique features. All right, back to the command line, and this is what you've already seen probably, and when other people demonstrated or used Git, or maybe their console in general. It's really convenient when working with Git so that you have an idea on what you're doing. What you see in the screenshot is you see these color-coded prompts. They allow you to, for example, track in which branch you are. In this case, I'm in the main branch. These are two different lines. How many files have changed? So if you change something, the system or Git will automatically detect how many files have changed. If you deleted any files from the source control, if you need to push them to another repository, stuff like that, that will also be very visible when you use a shell like this. In the Linux world, this has existed for years, but now we have some similar customizations that you can do to exactly Windows terminal, and that's why I'm using it to have the same effect. And this is a very simple customization. You can go very wild, so that you can have your let's say your Windows battery status in there, or the weather outside. Everything that you can think of can be integrated into this line, but I personally try to keep it simple and just have the basic Git information there. How do you accomplish this? Again, this is not needed. This is just eye candy, and it makes your life a little bit more convenient. So how do you upgrade your command prompt to have something like this? First of all, you need to have Windows Terminal. It's also open source from Microsoft. You can download it. You need a Powerline capable font, and what a Powerline capable font enables you to have is to have this little, and I'm going to this previous slide, to have these little glyphs, these little graphics. That is what a Powerline font, because it's all font based, what a Powerline font gives you. And a very good free collection of Powerline enabled and capable fonts can be found at Nerd Fonts. If you're using PowerShell as your default shell, as I do, you can download a few modules, open source again, which enable this pretty prompt. And I urge you to go to the Posh Git and the Oh My Posh modules. They're always funny names to see how they work exactly. Maybe I'll have to do a blog post, but I've got some references after the presentation on how you can prettify your font. And the font I'm using personally is Vira Code. We talked about the shell, but we also need to talk about the Visual Studio Code. Again, you don't need to use it, but it has some very interesting extensions that make your life a lot easier. These are the three extensions that I personally use in combination with Git. The first one is Git Lens. It enables you, when you are on a certain line in your PowerShell script, it will tell you line by line when this line was last changed in the source control, who changed that. You are able to drill down into the exact changes that were last made line by line. That's Git Lens. And there is Git History, which enables you to view your Git history of a file or the whole site or whatever you're using inside of Visual Studio Code. Very handy, so you don't have to go to the command prompt to look at the history or to GitHub. And last but not least, there is a GitHub pull requests and issues integration. So if you're working with other people on a common project, you might have some issues that you log in GitHub, which is additional functionality that GitHub offers you above Git. You're able to create and work with issues and assign issues from within the Visual Studio Code interface. So that's what this does. It also helps you with pull requests. And that's a concept that we're going to touch upon a little bit later in the presentation. So we talked about how command line can be used to interact with Git, with the source control system itself. There is another command line interface, or another command line program, which is the GitHub command line interface, the GitHub CLI, which is able to automate things that you would normally do in the GitHub web interface. For example, in this case, listing issues, but there are many more, or creating pull requests. And that's also something you can, this is a Linux example, but it's also something you can install on Windows. I use it from time to time. It's fairly new, but it's quite cool to have a neat integration with GitHub, so you don't have to leave your command line all the time. So that the GitHub CLI, which is also free. Many of these capabilities can also be achieved through Visual Studio Code or through another physical interface. All right, so let's get to the basic Git concept, the basic Git workflow, the basic Git commands. First of all, the basic Git workflow. Now, we have many commands in Git. We have probably 30 different commands in Git. We don't have any time to go over all of them. That would become a little bit too complex. So I think it's important to at least understand the basics very well. How do you work with Git on a day-to-day basis? What is the basic Git workflow? First of all, you need a repository, or we call it repos in the Git world. You need a repo. A repo is basically a folder with files, code, images, some PowerShell scripts, something else. So you need to create a repo on your own PC. That can be done through the command line, or you can, let's call it download. It's called cloning in Git. You can clone a repo from the internet, for example, from GitHub to your local PC. So if someone tells you, oh, you can download that from my GitHub page, well, you can go to GitHub and effectively download a zip file with everything in it. But that's for amateurs, let's say. If you have the Git interface installed, you clone that part of the code. And what happens then is, remember when we talked about distributed source control, you have your own mini source control system, your own complete copy of the code locally on your PC. And that's quite cool. So you don't only have the code, you also have the history and all the different changes and all the logs that are related to that code. You have that on your own PC. So you clone or create a new repo, and then you work in your local copy, again, distributed. So everyone works on their own local machine, independent of each other. No checking out, no locking of files because I'm working on this or that file. No, everyone is his or her own boss on your own file system. So what happens then is a typical cycle is you make changes to the script or to the code. You commit changes. That means, okay, I've done my change, include it in the source control, track what I've changed, and then you push it to a remote repository, for example, GitHub, when you're ready. You don't have to do that, by the way. If you're just working on your own PC, you have your own repo, you're not working together with other people, you can just keep committing to your own local repository, and that's it. And that's perfectly fine. The best practice there is to commit often. So don't work a whole day and then commit. No, make a few changes, commit, make some meaningful changes, of course, and try to make those changes as atomic, as small as possible. Because the smaller the changes you make, the ability to get back and to fix very exact things or very specific things is much easier. But if you're working with a remote repository, for example, on GitHub, you want to push that. So that's also something that many beginners don't understand. So you make your changes, you commit to the source control system, but you don't see it in GitHub. Okay, because you committed it to your local copy. Remember that the hierarchy, the diagram that I've shown you before, well, you make changes in your local repository, but if you're done, you still need to push them to the main remote repository in the cloud, for example, in GitHub. But also that also works the other way around. Other people might also make changes to their portion of the code and also commit that back to the remote repository. And your local copy will not automatically be aware. So then there's another mechanism, it's called Git Pull, where you pull from the remote repository regularly to stay up to date, because other people might have made some changes in the meantime. So you want to have your your own local repository as up to date as possible. So it's always this cycle of making changes, committing, pushing, and a lot of pulling to make sure you're working with the latest version of the code. And that's a cycle that repeats itself all the time. Now, we talked about a few concepts. I talked about cloning, about committing, etc. Let's put them all in one list so you know what they mean. First of all, there is what we call downloading an existing repository to your PC. That's called cloning. Then there is checking your changes locally, which is committing. And you always have to specify a message, a log message, by the way. Then you move your changes to remote repository, which is called pushing. You get changes from the remote repository that someone else made by pulling, or if you use multiple PCs, for example, those might be your own changes, but that's a little bit meta maybe. But what happens if multiple people made changes to the same file? We need to merge them together. And I told you how Git does not have the concept of locking a file or checking out a file. So if we have merging, we potentially have conflicts, and conflicts need to be resolved. Now, resolving conflicts in Git is absolutely not a good topic for a beginner presentation. If you're just with a few people, it's okay. But if you changed a lot of files or a lot of lines of code or in your script, merging can be quite complicated. But that's probably a topic for another talk. We also talked about branching already. So if you want to work on something that is new, or you want to work on a specific bug, or you want to introduce new functionality, it's a good practice to create a branch, which is another copy of the code where you can safely work on that new feature. And when you think it's done, you can merge that back to the main branch for everyone else to use. Now, if you don't have access to that main branch, because you don't want to people committing to, for example, I don't know, the Microsoft 365 patterns and practices GitHub repository. You don't want everyone just checking in code there. So if you want to do that towards a repository where you don't have immediate access, that's called issuing a pull request. That's something, or a PR. That's what many people do. So in order to make your code available to other people, that's a PR. And if you want to work on an open source project, it's a good practice to also create a fork. A fork is a copy of the code in your own, a copy of the code in your own, let's say, in your own GitHub account to work with. That's forking. Pull requests we already talked about. Remember, many of these things are practices, are just conventions. They're not enforced by the tooling. That's also very essential to understand. All right, we've got some 20 minutes left. There's some stuff to talk about yet, but let's do some. Let's show some basic operations of Git. With a little bit of luck, you will see my screen here. Okay, so what we're going to do is something very simple. We're going to go to GitHub. There is an existing repository there. We're going to get it on our machine. We're going to have our local copy. It's called cloning. This is my GitHub page. Everyone has their own GitHub page. Don't be alarmed by all the bells and whistles here. If you go to repositories, you can see that person's repositories. A few of them I have created them myself, like this one for TechTrain today. And my personal website is in one of these repositories. But there are also other repositories that I have forked from someone else. For example, Home Assistant here. I've got a Home Assistant automation system. I made some small changes where I wanted to check out the code, so I created a fork. So if you go back to my main page, you see something here, which is a small about me text, something that you can put up there. It's also relatively new, but that is also stored inside of a repository. So it's in the list of repositories somewhere here, but it's convention. It has always the name of your account. So it's Thomas Vochten. So if I go there, and I forgot to start my Zoom here. Let me start that. So if you are in GitHub, you can see you have got URL, github.com/Thomas Vochten, which is the name, is user account, and Thomas Vochten, in this case, again, is the name of this repository. So what do we see here? This repository contains only one file, this file, the readme.md. It's a markdown file. It's a it's a little bit like HTML, let's say, a simplified form, which GitHub uses to create your About Me page. But it is a normal repository like all other repositories. So this one has one file, but you've got repositories with millions of files. Even the Windows source code is now on GitHub, which has millions and millions of lines. So it's one file, and you can click on it, and you can see the file. Okay, nothing fancy. But what if we want to make some changes? Let's say this is a PowerShell script that we want to change. It works always the same. You can make changes here online if you want, but yeah, only amateurs do that. Let's say we want to create a clone of this repo to our local PC. And to get a clone, you copy on code, you click on code. There are different ways here. You can download the zip file if you want, but as I said, we don't want to do that. And there are different methods depending on your authentication. You can use the GitHub CLI that we talked about, but I'm going to use the default method, and that's through HTTPS. So what you do is you copy that URL here, you go to your command line, and you say git clone, and I already authenticated to GitHub, by the way. That's something that's not fancy to show here. And then you paste the URL, so git clone, and then that URL, and then you press enter. And it's fairly quick because it's just one file. And when we go to the to our PC, we see there is a one directory added, which is called Thomas Vochten. It's always the name of the repo. And then we have this color code that's coming in, right? So we are in the Thomas Vochten directory, and we are on the master branch. So this is still called master and not main. So it's green, which means that there's nothing else that we need to do. We're okay. So if we have a look at the contents of the directory, we've got a README file. Okay, let's look at that in Explorer. How does that look like in Explorer? Exactly the same, just one file. Now, how does Git work? There is a hidden directory here. If I do hidden items, you see a .git directory here, and that's where all the Gitty stuff is stored. Never ever mess with this directory, or you will break everything. That's also why it's hidden. So let's hide it again. So now it's gone. So let's now make some changes to the file. There are multiple ways on how you can interact with this file. You can do that through Notepad or Notepad++. Let's use, Notepad++. Doesn't really look like anything. Let's do something else. Let's use Visual Studio Code. That's probably better. And then we have our directory, and we have our one file. So it looks a little bit like HTML. So what you can do now is you can change the file. What are we going to change here? Let's say, does PowerShell count? PowerShell is code 2. So we made a change to the file, we save it. And when we go back to our interface here, you see the color has changed. It's no longer green. It says, you changed one file. But if we go look at the directory, we don't see anything. If you want to have more information, you can type Git Status. Oops. So what does it say? It says, okay, you're on the master branch. It's up to date with the origin, which is the remote one. But there's one change that you haven't staged yet. Remember that we talked about staging. You have to tell the system, okay, this file is now changed, and I'm ready to commit it back to my local copy of the system. So first, we are going to add this. So you do git add, and that's the atomic changes that you make. So let's say if you have 25 files here, you can choose to only have one file committed back to the repository. Git add readme.md. All right, and then you can, if you want to be sure, do a git status again. It's turned green now, so it's ready to be committed. And now we are going to commit, git commit with 2 E's. And now you need to specify a message. PowerShell is code 2. Can be anything, of course. And then you commit it. And then you see that the colors changed again. So we changed from green to this light blue, now to pink. And this means that if we do Git status, we can get more information. Typing in front of an audience is always challenging. So it says, okay, your branch is ahead of the origin by 1 commit. I made 1 change related to what is on GitHub. So you can work like this the whole day. So you can make additional changes, add more files, for example, and do Git commits whole day. But that will still only be present in your local copy of the source code. If you think, okay, I'm ready for anyone else to consume this change, you can do Git Push. Now, it's a small file, so it should be very, very fast. It's green again. That means we're up to date. We have committed and pushed all our changes. We are ready. Let's go to GitHub and let's refresh the page. And it says now PowerShell is code 2. If you want to know what changed, you can go to this unique ID. Everything which is tracked in GitHub has a unique ID, and then you can see, okay, what did change between the 2 versions? Like we added a line, PowerShell is code 2. Now, how does the Git command line know where to push this to? That's called that's a content of Git remote. So if you do Git remote -v for verbose for more information, you can see that it knows when we cloned it, it also configured a remote. And it says, okay, the origin is github.com/thomasvochten.git. So that's that's how it knows where you go. If someone would have made changes to that repository, someone else, you can also do Git pull. In this case, it's not going to do much because the remote repository hasn't changed a bit. So that's okay. Some last thing, I've got presentations GitHub repo, which I have already cloned to my PC. Let's add the today's presentation to it. I've already prepared it here in a directory. Let's go back. Let's put it here. Tech train. Let's go to that directory. It also says, well, you changed something. And in this case, we didn't change in Visual Studio Code. We just changed something in the Windows Explorer. You added a directory, git add. You can also do git add star that will add all changes. In this case, that's perfectly fine. And then we commit with a message, which is a log message, basically, detecting 1st of April 2021. It's committed to my local repository. It created a PDF file, and then we're going to push that also to the remote repository, which is another repository, of course. So if we do git remote -v, you see, okay, this is going to thomasvochten/presentations.git. So that's the basic workflow. And if we now go to presentations, we should see our PDF file there. Tech train. Here's the PDF created 40 seconds ago. So that's the basics of working with the command line. Of course, there's a little bit more to it than just that, but for the basic workflow, that's all you need. All right, about commit messages. Many people have a tendency to just do meaningless commit messages. It might be a good idea if you're just working on your own, but if you're working together with multiple people, it's always a good idea to have meaningful commit messages so people actually know what you did. In this case, I worked with a repository that already existed that I created in GitHub. But you can also do the other way around. You can create a new repository on your local PC with Git init. That will make the current directory a Git repository, and then you can also push that to a remote repository to GitHub. But if you create a repository on GitHub, you will be presented with this page, and then you can even, if you want, copy these exact commands and connect your local repository to the remote repository. So that will GitHub is usually quite helpful. All right, we've got 8 minutes left, so time to talk about where to go next. We only touched upon the basics, the very basics of Git. So the first thing you need to do is get acquainted or get friends with the traditional cycle of Git clone, commit, push, and pull. If you know that, you already are way ahead of many other people. It's the simple basic commands that will get you the furthest. If you know that, it's very handy to learn how to work with remote repositories. So fiddle around with Git remote, clone a repository from GitHub, or vice versa, put your repository in the cloud, stuff like that. Create your first branch and merge it back in. That's something you can do. So you just create a private repository in GitHub, you clone that to your local PC, and then with the git branch command, you can create a new branch if you want, and then make some changes and then merge that back in and experiment a little bit with that. Forking an existing repository, for example, in my case, the Microsoft 365 PowerShell repository, for example, might be a good candidate to have a look at, and then issue your first pull request. I'm going to go back to pull requests in a few seconds. Branching and merging. The essence of branching and merging is relatively simple, but it can get quite complicated, especially if you're branching and branching and branching and branching. So sometimes it's not always easy to get a good oversight of what you're doing. So yeah, try to make up a set of rules, let's say, on how you want people to interact with your source control system. So the way it usually works is you've got your master or your main branch, and then you create a branch for something you are working on. In the meantime, some people are making changes. You can merge those changes back into your copy, create additional more work, and then merge your changes back into the master branch or main branch. And that's usually the way it goes. Now, when merging, you can have some conflicts. We talked about that already, but that's a more advanced topic. So it's a good idea to put your own scripts in a private GitHub repo or a public one if you want to share what you're doing. But there are also many other community activities that you can contribute to, and it just doesn't have to be code alone. It can also be documentation, for example. That's what not many people realize. You can also take advantage of additional capabilities of GitHub in this case, for example, automation, now that I'm seeing PowerShell on the slide here. Another next step you might want to take is automating something with Git through what is called Github Actions. So you can automate a workflow where you create your own PowerShell module and maintain it in Git. And when you push something to the main branch, that automatically that module is prepackaged and sent to the PowerShell gallery for publication, for example. That's what many people do if you're in the PowerShell world. It's really, really cool. Personally, I have you saw my website repository. I'm using a static site generator, but that's, again, a completely different topic. And whenever I make a change to my main branch, I add a new article. GitHub Actions will pick that up, compile that, and push that to an Azure website, for example. So that's all done with just a few keystrokes. That's what I'm doing myself. And if I can do it, you can certainly do it too. So contributing to documentation, I just wanted to show you this. It is entirely possible to do that through the Git command line, but it's also possible through docs.microsoft.com itself. So you've got an edit button if you see a page that you want to change. And believe it or not, I'm not a developer, but I made some changes to the SharePoint Framework development environment page. Let's not go into details there. So then you're automatically created a fork of that documentation in your own GitHub account. That's what you see here. We created a new fork with the documentation. And they guide you through the process. So you make your changes, and then you create a pull request. That means you're asking the main the main people of the documentation in this case, to merge your changes or to pull your changes back into the original source. So it gets published, in this case, on docs.microsoft.com. In the beginning, the word pull request is a little bit strange, because if you do git pull, you are merging code from somewhere else inside of your code, and a pull request seems to be the other way around. But yeah, that's deal with it. That's just how it is. It's called a pull request. So a pull request is asking someone else who maintains a repo to introduce or to integrate your changes. That's a pull request. And if it's a repo that you don't own, like in this case, I don't own the SharePoint Developer Framework documentation, that gets there is an approval workflow that gets kicked off, and people have to look at what you're doing and approve that. And eventually the code will end up in the right repository. So how you typically contribute to open source, it's more or less the same as how you work with the local changes. The biggest change there is that you fork the repo. So you create a repo in your own account, you make your changes there, and then do a pull request, and then you wait for the pull request to be accepted, and then you can remove the fork. It's important to learn about pull requests etiquette. Many people have specific forms or specific formats that you need to maintain in order to get accepted, because some of these repos are very, very busy, and they don't want to have 25,000 people committing or making pull requests in 25,000 different ways. So learn about the pull request etiquette, how to do it, but also what you contribute back. For example, if you think it's a good idea that you refactor a whole PowerShell module just because it applies to your coding standards, not there, but the code itself doesn't really change, yeah, it's probably not a good idea, and your pull request will probably not be accepted. Some final key takeaways. Getting started with Git is relatively simple, but the learning curve can be quite steep once you go beyond the basics. Definitely don't be afraid of the command line. I really urge you to start out with the command line and not even install GitHub Desktop. But if you want to have a look with Visual Studio Code, that's also possible. I even haven't shown you the integration with Visual Studio Code, because you can also push and pull from Visual Studio Code and add Git Status. It's all built in. So when you're working with your scripts, commit, push, and pull as often as you can. That's how you take full advantage of the system. Don't stop here. Absolutely go and see how you can contribute to other people's code. These are some additional resources that you can have a look at. There's a very good video series by Scott Hanselman who explains the really basics of Git and also goes a little bit further than I did today. Really, really, really interesting as always. And I included 2 articles, the Git documentation, which is quite good actually, and how to set up Windows in Powerline in Windows Terminal to get the fancy prompt. Then I want to thank you for your attention. I hope you haven't fallen asleep in this warm weather here in Belgium. If you want to download the slides, we uploaded them live during the session, and they are available in my GitHub repo, and scanning this QR code will get you there. All right, thank you very much. And if you've got any questions, I'll be around in the chat, or you can unmute yourself and ask them now. Thank you very much.